My viewers to my YouTube channel. In today's lesson, we are going to be looking at logarithm and logarithmic equation. Now, if today na the first time when you come across this YouTube channel, I beg, no forget to subscribe. As far as you be student who dey prepare for jamb or you are preparing for waec, subscribe to this channel because we have a lot to deliver to you. Class, we are going to be looking at logarithm and logarithmic equation. First of all, I will show you how to pronounce logarithm. Before we do that, I beg, the short form of writing logarithm, now we dey write as log. Help me pronounce am. This thing is called wetin? Log. So if you wan write logarithm for mathematics, you know dey spell am. We dey write am as what na? Log. Now, how do you pronounce a number such as this? How do we pronounce this? Please, it is called log 8 base 2. This one na log 8 base 2. If I write number like this, see am. This one is pronounced as log s raised to the power of 3 base wetin? Base y. So the one wey dey here na the number, but the one wey dey here na the wetin na the base. Now, if I write something like this, abeg help me pronounce am make I see if you don learn am already. Pronounce this guy. This one is log of the square root of a base what? Base b. So the number na im be this one, the base na im be that one. Now, if I have something like this, what is this? This one get number but e no get base. And as e no get base, know say the base na wetin na? Base 10. So anytime wey dem give you logarithm problem, say dem no put the base, know say the base na wetin? Base 10. So if I write something like log x, abeg, it is pronounced as log x base wetin na? Base 10. So any logarithmic problem without a specified base is automatically in wetin na? In base 10. So that should be noted. Pronounce am abeg. Log 8 base 2. Log s raised to the power of 3 base y. Log of the square root of a base b. This one log 12 base 10. This one log x base wetin na? 10. Thank you very much. Now, but before you fit solve problem for logarithm, you will need to understand the laws of logarithm. Okay, come closer. Get your book and your pen. May we quickly discuss wetin we dey call laws of wetin na? Logarithm. Let's quickly discuss that. Wetin be the laws of logarithm? The first law of logarithm says, law number 1, it says that the logarithm of a number to the same base, the logarithm of a number, abeg, write am down, a number to the same base is 1. The logarithm of a number to the same base is equals to wetin? 1. That means if I get something like log a base a, the answer is equals to wetin? 1. If I get something like log x base x, the answer is equals to wetin? 1. If I get something like log 10, no forget say if I write log 10 and no put base, shey you know say the base na 10. So the logarithm of 10 to base 10 is equals to wetin na? 1. So that one na the first law for logarithm. Say the logarithm of a number to the same base is 1. Log s base s is 1. Log 10 base 10 is wetin na? 1. Okay? The second law for logarithm wey I wan make una learn, this law says the logarithm of 1 to any base is equals to 0. I go explain. The log, you know the way the short form of writing log is to write log. So the log of 1 to any base is equal to 0. See wetin I mean? If I get log 1 base s now, as far as say na 1 dey here, to anything wey dey here is equals to what? 0. If I get something like log 1 base 5 now, the answer is equals to what? 0. If I get something like log 1 now base 10 is equals to what? 0. So the first one be say the logarithm of a number to the same base, which is this first one, is equals to 1. But the second one be say the logarithm of 1 now, no matter the number wey dey here, the answer na 0. So log 1 base 5 na 0. Log 1 base 10 na wetin na 0. So this one na the first law of logarithm. This one na the second law of logarithm. And I hope say you understand this law wey I discuss now. Now, when we go to law 3 of logarithm, just like I told you, if you don't know the law, you no go. If you don't know the law, you cannot solve the question. Let's talk about law number 3. Please, I want you to pay close attention to this law. This law number 3 says, it says if I get log a raised to the power of s base b now, something like this. If I get log a raised to the power of s base b, wetin I go do? You see the power wey dey this a, you carry am go the back of the log. You carry am come like this, come this place. So that means it go be equals to, see this s now, now you go use start am to now be back of the log. Now as you get log, you get s log what? A base what? Base b. I will give you another illustration. If I get log m raised to the power of p base x, for instance, the power of m na be p. That number will be taken to the back of the log. So we are going to get wetin? P log wetin? M base what? Base s. So any number on top should be taken to the back of the log to multiply the log. I'll give you illustration. E.g., if I get log 8 base 2, how do I simplify this? How? Very easy. 8 na 2 raised to power 3. I hope so you know. Like this 8 now, na 2 raised to power 3. This is how you can do it. Write 8 for somewhere. Look for number wey go divide 8 without say remainder no dey. Okay? Now let's say the number now na 2. Use 2 divide 8. Wetin you go get? 4. Use another 2 divide this 4. You'll get 2. Use 2 divide this 2. You'll get 1. So how many 2 now we use divide this 8? No be 3. See am. 1, 2, 3. That means this 8 now na 2 raised to power wetin na 3. So that means this log 8 base 2 na the same thing as log wetin? 2 raised to power 3 base what? Base 2. Are we together? Now, you see this 3 now. You carry am go the back of the log. You can get 3 log wetin? Wetin go remain here? 2 base 2. And you know say log 2 base 2 is equals to wetin? 1. So if I use this guy, optimize am, you go remain wetin na 3. Another one again, if I get something like log 81 base 3, how do I simplify this? Very easy. This 81, look for number wey go divide 81 without remainder. That number na 3. See am. If I write 81 like this, see am. 81 divided by 3 will give us 27. 3 going to 27 will give us 9. 3 going to 9 will give us 3. 3 going to 3 will give us 1. How many 3 divide 81? Count am. 1, 2, 3, 4. So that means this 81 wey dey see here na log wetin? 3 raised to the power of 4 base what? Base 3. Okay, now what will I do to that 3? That 4 here. Shebi you carry am go the back of the log. So you get 4 log wetin? 3 base 3. And you know say log 3 base 3 na 1. So if I cancel am like this guy come remain wetin na 4. So you know the add and top. This one na im be the wetin? The third law of what? Of logarithm. So we are going over to law 4 and law 5. Now law number 4. The fourth law of logarithm, don't forget we are still talking about the law. If I get log a raised to the power of x base b raised to the power of y, how do I simplify this? Very easy. This a has a power x and this base has a power y. Divide the power of the number by the power of the base. Like this s now, write am, divide by this y, then wetin go remain na log what? A base what? B. Very easy. Now I will give you example. E.g., watch this. If I have log 81 here and I have base 27 here, how do I do this? Very easy. 81 na 3 raised to the power of 4. Like if I get 81 and you divide am by 3, you go get 27. Divide am by 3 again, you get 9. Divide am by 3, you get 3. Divide am by 3, you get wetin? 1. So na 4 3 divide 81. But if na 27 you want divide, na 3 3. So that means this 81 now is 3 raised to the power of wetin? 4. But this 27 na 3 raised to the power of wetin? 3. So I go divide the power of the number, which is 4. I go divide it by the power of the base, which is what? 3. Then wetin go come remain now? Log 3 base 3. Abi now? So this log 3 base 3 now go cancel out because logarithm of a number to the same base equals to 1. So what will now be remaining now? 4 over 3, or 1 whole number 1 over 3. I will give you another illustration. If I have log 16 base 8, for instance, okay, or log 16 base 8. If you break down this 16 are 2 raised to power wetin? 4. This 16 wey there. Why this 8 now 2 raised to power what? 3. Okay, so I'm going to divide the power of the number 4 by the power of the base 3, and you'll be left with log 2 base 2. So they will cancel out, and then you have 4 over 3. Now let's take another illustration on the fourth law. Let's take another illustration. Now how many of you remember that if I have 0.1, for instance, now 10 raised to the power of minus 1. Why? Because the 0 is at the back. If I get 0.01, it is 10 raised to the power. How many 0 there here? Minus 2. If I get 0.001, it is 10 raised to the power of minus 3. But in the other way around, if I have 10, now 10 raised to power 1. If I have 100, now 10 raised to power 2. And if I get 1000, now 10 raised to power 3. So understand the difference between this one and this one. Now if I can give you log 0.0001 base 100, for instance. What will this give us? Very easy. How many zeros did the back now? 4 zeros. So it will be 10 raised to the power of minus 4 because the 0 is at the back. But this one is at the front, so it will be 10 raised to the power of 2. So what will this give us now? Carry this minus 4, go back, divide them by the power of the base, then you will be left with log 10 base weighting 10. They will cancel out. Minus 4 over 2 now weighting minus 2. So this is the fourth law of weighting, logarithm. Let's look at the fifth and the sixth law of. Now let's look at law number 5 of logarithm. The fifth law of logarithm says that the logarithm, let's say we have log a base x plus log b base x. Now seeing that these two guys have the same base, what do? Very easy. You simply take one of the base, which is base what? X. Now because you have a plus b here, you simply times them together. So you have a times b to give you ab. So it is equals to log ab base what? Base s. Now let me give you an illustration, class. If I have log 25 base 10 plus log 4 base 10. Let's do this quickly. Now, take a look at this. These two guys have the same what? The same base. So as they get the same base, this is what we'll simply do. You have log 2 base 10. Why? Because they have the same base. Then what do you do the number? You have 25 times 4. We times these two. We pick one of the base. So we have what? Log 2 base 10. 25 times 4 will give us weighting 100. So you have log 100 base 10. This 100 can further be simplified so that we have weighting log 10 raised to the power of 2 base 10, which is this 100. Then what now happens to these two? you take it to this place according to the word, the third law of logarithm. So you have 2 log 10 base 10. So log 10 base 10 cancel each other. The answer is equals to wetin na 2. Very easy. So whenever the base are the same and you have plus, pick one of the base, then what do you do to the power? You do what? You multiply the numbers. Okay? Now if I have something like log 8 base 2 plus log 25 base 5. If you watch very well, you see that the base here is 2 and the base, so you cannot pick one of the base in this case. You solve them separately. So here we have a condition of different bases. Okay? Now as we get different bases, now you do them separately. This guy now 8, now 2 raised to the power of 3. You know I showed you how many 2 can divide 8. So here you have log 2 raised to the power of 3 base what? Base 2 plus log, what about 25? 5 raised to the power of 2 base what? Base 5. Are we together? Yeah. So these 3 now, you will go back. You have 3 log 2 base 2 plus these 2 now go back. You have 2 log 5 base 5. So they go cancel. Log 2 base 2 now 1. So you go remain 3 here plus cancel 2. That will give us wetin na 5. So whenever the base not be the same, use the previous laws. But if the base not the same, pick one of the base, multiply the number. If now wetin na plus. Okay? Now we are going to do the last law for today. Then we'll continue in our next video lesson. Now law number 6. When you see minus here, watch this. You have log A base x minus log B base x. Remember, if we had plus, we'll take one of the base and multiply the numbers. This time we have what? Minus. So we take one of the base, we divide the number. So you are going to say is equal to log to base 1 of the x, then it becomes A over what? Over B. That's it. So for instance, class, if I get log 49 base 7 minus log 7 base 7. Since we have the same base, what do we simply do? Very easy. We have log of what? Base 7, Abi. Then you do 49 over 7. We are dividing because of this minus. So we are going to get log 49 over 7. We are dividing because of the minus. So when we divide 49 by 7, we have 7. So we have log 7 base 7, and that will give us wetin na 1. Don't forget, if the bases are not the same, they should be done separately. For instance, if I have log 49 base 7 minus log 1000 base 10. Now this is base 7 and this is base 10. Because the bases are not the same, it should be done separately. So what do we have here now? What do we have here? We have solution. We have log. This 49 is 7 raised to power 2 base what? Base 7. Minus 1000 is what? 10 raised to the power of 3 base what? Base 10. So what do we simply do? We will carry this guy, go the back. You have 2 log 7 base 7 minus 3 log 10 base 10. So log 7 base 7 is 1. So you are left with 2 here. Log 10 base 10 is what? 1. So you are left with 3 here. So we have 2 minus 3 to give us minus 1. Now the answer be that. So whenever you have different base, it should be done separately. Now we are going to take just 2 jamb questions on this, and we'll continue in our next class. Now let's take this question from UME, that is University Matriculation Examination by jamb, 1982, number 16. How do we solve this? Very easy. Remember, the law says that if there is minus here, you pick one of the base and you divide. So according to the law, this numerator will give us log to base 10 of what? 8 divided by 4. See, that's for the numerator. all over the denominator. Now you have log of base 10, then you have 4 divided by 2. So what do we have now? 8 over 4 will give us 2. Abi? Good. So you have log 2 base 10 over, yeah, what do you have? The same thing. 4 over 2 will give us 2. Log 2 base 10. So if I have log 2 base 10 and I have log 2 base 10 here, this cancel this. My answer is equals to 1. That's the answer. So it's very easy. Now let's take the next question. UME 93 number 22. Let's solve this quickly. Remember I told you that whenever you have plus, you times the numbers if the base are the same. And whenever you have minus, you divide the numbers if the base are the same. First of all, we are going to do this, class. We are going to do this. Remember that this number here, 1 over 4, which is at the back of this log, came from here. The law we did, I told you that if you have log a raised to the power of x base b, that this x will go to the back of the log, so that it becomes x log a base b. So it should be noted that any number we dey here, now here affects d. So more carry and go back. For here you have log a raised to the power of 1 over 3 base 10 plus log weighting. Watch this. This 1 over 4 now here from come. So you have a raised to the power of 1 over 4 base what? Base 10. Then this 1 over 12 now here for come. So you have minus log. Watch carefully. This is a raised to the power of 7 before. Then bracket 1 over weighting 12 base what? Base 10. Wow, very easy. So here now you have log a raised to the power of 1 over 3 base 10 plus log a raised to the power of 1 over 4 base 10 minus log weighting a raised to the power. If I multiply 7 by 1 over 12, I will do 7 times 1 to give you 7 over 12 base what? Base 10. Whenever you have a number like a bracket b over c, please always use the a to times the numerator, not the denominator, so that you have ab over c. That's what I did here. 7 times 1, 7 over this 12. So what do we do now? Because they all have the same base, what do we simply do? We go take one of the base 10, then for here will be plus. Now we go times a raised to power 1 over 3 times a raised to power 1 over 4, which is this 2. But when we have minus, we are going to do what? Divide. So we are dividing with weighting now. A raised to the power of 7 over 12. Wow, very easy. The law of indices told us that if I have a raised to the power of 2 times a raised to the power of 1, according to the laws of indices, when multiplying two index number, you have a raised to the power of 2 plus 1 to give us a raised to the power of 3. So in this place now, we are going to pick one of the base here, then we add this to this. That's what we are going to do. So we are going to have log weighting a raised to the power of 1 over 3 plus 1 over 4. We'll pick one of these base, we call plus these two power, all over a raised to the power of 7 over 12. Everything now to base weighting base 10. Wow, very easy. Now let's quickly. Now watch this. This is what we have now. We have this. So we are going to add these two together. We are going to add it. To add it, what's the LCM of 3 and 4? The LCM of 3 and 4 is 12. So we have log to base 10 of a raised to the power of, in this place you have 12. 12 divided by this 3 will give us weighting 4. 4 times this one will give us 4. Plus 12 divided by 4 will give us 3. 3 times this one will give us weighting 3. All over a raised to the power of 7 over 12. See? That will give us log to base 10 of what? 4 plus 3 now weighting 7. So we have a raised to the power of 7 over 12 over weighting a raised to the power of 7 over 12. So if these two guys are this, so we can cancel them, so that we have log to base 10 of what? If I divide this by this, I'm going to get 1 to base 10. And the logarithm of 1 to any base is equals to what? 0. So the answer to the question is what? 0. We have come to the end of today's class. If now today be the first time we dey come across my YouTube channel, abeg subscribe to this channel and share this video to your friends. I'm going to see you in my next video lesson. Thank you very much.